Before we conclude this tutorial with the rendering part, we've got one more essential step to do: baking our shaders for the lighting department to import later. Our work is now completed and approved, and we are thrilled with the results. Aren't we? Of course we are. Time for baking those shaders. So, what exactly is LookFileBaking? It is used to bake a look file for a scene graph location specified in the root locations field. Let's bring a LookFileBake node to see what we will be working with. So here, we have two inputs, the original and the default pass. The look file is used to compare the scene graph generated at those 2 points within the node graph. Then it saves the difference between the original and the default pass, or any additional passes. Now, let's start to connect these inputs to the rest of our node graph. Remember when we created those dots called in and out with a special color earlier in the tutorial? It is now time to use them. The in dot represents the point in the recipe where the bake asset has no materials assigned. This is the point to bake from. The out dot is the output from downstream in the recipe, where the asset has the look we want to bake. We will create 2 teleport nodes and call them the same, in and out. We are being so consistent with our naming. Real pros here. We will add the root world location and enter the path relative to the project directory and a name for the look file in the Save To parameter. Now, click the Right Look File button. The Right Look File dialog appears, and Katana starts baking out the look file. Any differences detected between the scene graph generated at the original input and the scene graph generated at the pass inputs are written to the look file. As the out dot is located in the node graph below the variable switch, it will bake the shader selected in the graph state variables. We can now begin testing our work to make sure that our materials have been baked properly. To do this, let's create a new backdrop named Testing. We will bring a look file assign node and drag in the same asset path we used to bake our materials. In the asset field, we will load the KLF containing the materials we just baked. To apply the changes specified in the look file assign for a specific pass, we use a look file resolve node. This node is added to our test recipe. In the pass name parameter, we could enter the look file pass to use. But if no look file pass is specified when attempting to resolve, the pass will fall back to the default pass. We can verify the proper assignment using a switch node. We will trigger some renders and check if our robot appears with the assigned shader. If everything is in order, meaning our robot is all dressed up, it will confirm that our baking process was successful. And once again, it worked. We will add 4 dot nodes below each material assigned node and rename each one before plugging them into the variable switch node. For tidiness, we will add some teleport nodes for each of those inputs. Let's add our 4 additional passes on the LookFileBake node. We add additional passes by clicking on Add, then Add Pass Input. This is useful for adding render passes, but also for other baking passes, such as different variations or edits to a material. A new pass input will then be created on the node, and a pass name field will be added to the pass list. We will rename each of our pass input to match our shader variations, so white, rusty, blue, and camo. Each of these variations will be baked into the KLF we generate. Let's save it as another version and click Write Look File. We can test our work once again, but this time, we'll assign some of the additional passes we just baked. Starting with our default pass, we can check if it is working. And yes, it is successful. We can see our white shader selected in our GSV being assigned. We can try another shader, such as camo. And we can notice that this process is also working correctly. If we want to modify a previously created shader without altering the original NMC, we can do so non-destructively by creating a network material edit node. Drag the path of the material to be edited, repopulate it, and tweak any parameters as needed. For example, we will use the pink emission texture file from the camo robot on the white shader. Then, add a color correct node to the emission file to accentuate the intensity and vibrancy of the pink by adjusting the hue, saturation, exposure, and multiply values. To finalize the look, we will add a slight pink tone to the diffuse file using another color correct node. Once the modifications are completed, we can bake the shader again and test it through our testing tree. A new LookFile assign node and a new LookFile resolve node are brought in to clean up the scene, flush the caches, and assign the white input. By triggering a render, we can see that our character is now a pink emissive wonder, ready to dance the night away. To summarize this fifth video, we created a LookFileBake node where we bake the differences between two node graph locations using two teleport nodes called in and out. We tested our work by bringing back another teleport node and assigning the KLF to our asset with a LookFile assign node. We added a LookFile resolve node and used a switch node to quickly verify if our KLF was correctly baked. We baked additional passes for each shader variation, used a network material edit to modify one of our original shader, and tested all our passes through our testing node graph. Our KLF is now ready for the lighting department. Good job, everyone!